Hello everyone, this is like a blast from the past. We just finished our textbook and all of a sudden we're going back to chapter 10. What are we doing? Well, if that's running through your mind, it's kind of running through mine too. The reality is that there is some content that we skipped. I wanted to finish the most important stuff. Now, I'm not saying that this chapter is stupid or that it's unnecessary, but there are other things that I feel like are higher on the totem pole to learn. For instance, chapter 18 over organic chemistry, very important. Characteristics of hydrogen, not incredibly important, but still very useful for chemistry. And so don't throw this chapter already out in your mind thinking that it's just dumb or lame. These things are very useful. And they are important. Now, I'm not having you necessarily memorize every last characteristic of these nonmetals. It's not like I'm going to, on the test, ask you, hey, at which temperature does hydrogen boil? Because the reality is that is not important. You can just look that up in a textbook. And really, I'm sure that there's very few chemists out there who actually know that. But some of these things are very important. Hopefully they build on your knowledge of the periodic table. Because what we were learning, and what I was telling you is important to learn, is the characteristic of each column of the periodic table. So here's the alkali metals. They have 1 valence electron. They want to give that up. Here's the halogens. They have 7 valence electrons. They're very upset that they only have 7, they don't have 8. And so these descriptions are useful, but there are minor differences between, for instance, fluorine and chlorine. One you'd want to get on your teeth to clean it. The other one, I wouldn't necessarily want to bleach my teeth. That just doesn't sound appealing to me. But anyway, let's talk about 10.1 over hydrogen. It's gonna be 1 nonmetal each time we go through this, and I've combined certain sections just because they're a little bit smaller, so it should be an easier week actually. And hopefully we can just coast through the characteristics of hydrogen, and then tomorrow it's going to be a different atom or element, and then of course the next day and the next day and the next day. All right, hydrogen. Before we talk about hydrogen, we have to talk about descriptive chemistry. Descriptive chemistry and descriptive chemists describe chemicals that are important to human life. This is important because it is a field of chemistry that just deals with stuff we'll use. You see, there's a lot of things out in chemistry that are just pretty far-fetched. You know, we're making chemical compounds to attempt to get, some medicine or whatever. Descriptive chemistry is like, okay, we deal with hydrogen. How do we make it? Why are we making it? Etc. Hydrogen is the simplest element, consisting of a singular proton. Hydrogen is also the most abundant element in the universe, making up 90% of the known atoms in the universe. That means it's everywhere. But on the Earth, it's actually not as everywhere. And now we'll talk a little bit more about that as we go along. 99.989 of hydrogen, percent of hydrogen is hydrogen with just 1 proton, no neutrons at all. And there's a very small fraction of these that have a singular neutron. And I believe, some of you looked that up, it was deuterium. And then some hydrogens actually have 2 neutrons, which, let's see, hydrogen with 2 neutrons, tritium, that's it. And so, anyway, that stuff's unnatural. It doesn't occur in nature, but we can make it for nuclear purposes. Hydrogen is pretty useful, and here we have a picture of the Hindenburg. And in 1937, it gave hydrogen a pretty bad name because it was an airship with like 90 people on it, and about half of them blew up. And originally we used hydrogen to help things float because it does float, but it's also reactive and very flammable. So instead today, to make things float, we use helium, which is, I mean, the worst that it does to us is make us talk a little funny when we suck it in. Hydrogen, you know, it's a little bit more dangerous. And even though hydrogen's a lot easier to find and use. Hydrogen is a colorless, tasteless, odorless gas with a low density, suitable for things like balloons and blimps. That's hydrogen's properties. Its preparation. The most important commercial method of preparing hydrogen is through a process called steam reforming, where we take methane, which is very plentiful on the earth. You ever go to a farm and it just smells like a farm? You kind of smell that cow manure smell. That's methane. So, I mean, it's everywhere. In some places more than others. They take methane, combined with water, makes carbon monoxide and hydrogen. Then they take that carbon monoxide, combine it with more water, and it makes carbon dioxide and hydrogen, producing at the end 4 hydrogens, while only using essentially 1 methane. And your textbook actually, for whatever reason, asks you on a lot of these section reviews to write the chemical process and the formulas used to make this stuff. And I'm trying to give you them in the video series itself so you don't have to go searching the book for this chemical reaction. But methane reacts with the steam when catalyzed by nickel. Preparation continued. A lab method of producing this is through electrolysis of water, where you essentially split water in half. I'm going to show you a little bit about the electrolysis of water. I'm going to do a small experiment sometime later on in the week, hopefully. And all you do is separate water into hydrogen and oxygen. You collect it, and then you can actually kind of light it on fire. It's pretty cool. And there's some compounds which do this. I'm going to use a very common compound involving potassium that splits water in half. And that's a little bit better for me to use than electrolysis. Batteries and we just don't seem to get along, so that's okay. Uses of hydrogen, biggest use commercially is called hydrogenation. It's where you have something with double bonds. You see double bond here, double bond here, double bond here, and you take it away and form just single bond. So if you shoot 2 hydrogen at that, the double bond goes away, 1 hydrogen goes here, 1 hydrogen goes here. And it makes an unsaturated fat into a saturated fat. And that's very useful when we want to produce saturated fats. Consider the fact that saturated fats are solid, unsaturated fats are liquid. So if we're trying to make a solid fat, let's say we're trying to make popping oil for popcorn, and you want a solid fat. And I actually have some popping oil. Let me go grab it. We've been eating a lot of popcorn in our recent times of quarantine. See, some of this popping oil is liquid, and it is just made out of fat. I mean, literally, the ingredients are flavor and fat, you know, and oil is a fat. It's a nicer word for it. And then here is solid fat. Yeah. Just artificial butter flavor and fat. And it's solid. Well, this has less double bonds than this does. This is a more saturated, and this is a more unsaturated fat. And this was probably produced by hydrogenation. It's a very easy chemical process. Real theater popcorn. Popping oil. Cool. We eat a lot of popcorn. And that's it. do section review 10.1, page 151, and we'll see you tomorrow when we talk about hydrogen. So that's all for today. I'll see you guys later.